Right, hello and welcome to this brief summary of the AWSOM system from end to end. Basically, we're going to talk about the who, what, why, where, when of the AWSOM suite of products. What is AWSOM all about? It stands for a well system for ongoing maintenance. So the idea is that through technology, we're trying to make sure the wells don't break. So rather than rely on ambulance maintenance, the idea is to be proactive and fix them before they break, or have an idea of what they're going to do break, when they're going to break. Okay, now we're on to the who. Who is this for? Well, it's for people who rely on these hand-pumped water wells, and there are about 1 million hand-pumped wells in Africa, and people rely on the water from them. They just don't harvest the rainfall. They rely heavily on these hand pump wells. We're focusing in Tanzania. Why? Because there are contacts there. The world's a big place. But the idea is to try and establish some prototypes in Africa working, and then maybe develop more sophisticated models so that we try and help prevent the deaths. This is where we come on to the why, because in Tanzania alone, the Office of National Statistics out there say that roughly 6,000 children die per year due to drinking toxic water. So basic commodity of water. So that's why we're trying to do it. And it's mainly the children, because they haven't built up the immune system. The adults get very sick and diarrhea, but the children get dysentery and die very quickly. Right, now we come on to the how. How are we going to do this? Well, it's through the provision of the AWSOM system.
There are 4 basic blocks and we'll go through them one by one.
AWSOM consists of a wellhead unit, an item that's affixed to the pump, spout of the pump, and that transmits information to a head office, and there can be a base station in the head office which then exports the information on the well into a spreadsheet, and that spreadsheet then through a few clicks of a button can export it to a website. Now we come on to the when. Well, I've been looking through records, and we actually started this in 2016. It's amazing it's 2021 now. So we have gone through an enormous learning curve and have now come up with quite a robust, still a prototype, but then there's always improvements we can make. But the idea is to establish these prototypes in country, more of them, and leave them for a year operating, and so we can learn more about operational use. We've had one return for analysis. Okay, how have we done this? We started the project on focusing on the wellhead unit itself. The wellhead unit sits on the well spout and detects any movement in a radius of 3, 4, 5 feet of that well. It will detect and it will count the number of 30-second units that well is active. And we learned that analog devices that we were using were a little bit old-fashioned and took too much current, although it worked very well in UK. Within 3 months, 12 weeks, we decided that a big 10-watt solar cell was inappropriate on a great big tower. So just no. Eventually, we bit the bullet and we went everything into digital, and we are now using one Arduino. They are fantastic devices. I haven't used one before, and they are wonderful. Low cost, reliable, robust, fantastic. Can't praise them enough. That variable unit that we're going to put in place in Tanzania for a year, learn what it can tell us. And in the meantime, though, we'll be trying to improve the systems view and go PCB and maybe go FTP and Sigfox and a whole load of other things that we've learnt along the way. Okay, that summarises in just over 5 minutes what's taken us 5 years to do. The top left-hand corner there it represents the first prototype using analog sound. To split the frequencies, do some spectrum analysis, and define where the high frequencies were and how long the water was talking about, and then updating a talking programmable calculator and sending it back over the mobile phone network. Took too much power, then we moved into a hybrid of analog, once again microphone, and programmable logic controllers into the phone again. But even that was saved power, but it still took too much. But we'd never used Arduinos before, so we learned a lot during that twin Arduino route. And now we moved into one Arduino, just one Arduino, and we moved away from the microphone, and we're actually using Doppler radar, which is a great mechanism because it can go through, like sound waves, through the box, through the housing. And it's a great little chip from China, £3, something like that. And that's how we detect movement or activity around the world. And the Arduino, the little computer there, well, that is less than a fiver, and as I said before, they are fantastic devices. Right, now we come on to the software.
The software is split up into 4 main units: the wellhead unit, the complex base station, the very complicated AWSOM spreadsheet, and the website. But first, let's look at the AWSOM wellhead unit.
Okay, the software is, at the moment, it's about 1,000 lines of code. Could be improved, but when? Now, we have already some improvements made and some suggestions which have been absolutely fantastic. We got rid of strings and a whole lot of issues with those. The only trouble is that we need to test it for months, and if it puts a foot wrong, then we can't use it. Now, we haven't had that testing yet, and the idea is to get things out there as soon as possible. So at the moment we're going with the original code, but that might change. We are driven by data, not by dates. Who else said that recently in these COVID times? And I'm just looking at the Mars rover, which is about to land in about 15-20 minutes. Okay, so let's get systems out there into Tanzania, operating for a year or so. Then that will provide us more data to say, right, what are we going to do? Can we get away? We're sending SMSs, we're sending text messages at the moment back to a base station, which then updates the spreadsheet, which then updates the website. Could we go direct from the wellhead unit straight into FTP straight onto the website? No, we don't know. Text messages seem to get through far easier than FTP, but FTP coverage, mobile phone coverage in Tanzania is better than it is in UK. So we just don't know. As I said, we're driven by data and not necessarily dates, and it all depends on the data we get back. And we're learning, as I said, all the time. There is another alternative. Rather than using the mobile network, we could use another network called Sigfox. Now, Sigfox is all over Africa, apart from in Tanzania, which is a real nuisance. However, Tanzania and Sigfox have said they want to cover Tanzania, and they would put their first base station wherever we suggested it goes. Now we could put it in the epicenter of the center of the circle of the wells that we are looking at, because its range is far more than a mobile phone network, and the power consumptions are minuscule compared with what we're using at the moment, and power is key. Excuse me. So we don't know. There's a whole load of stuff we haven't we've got to investigate, but this is the possible directions that we're looking at. So far, so good, and let's hope it continues that way. Okay, cheers. Thanks very much for watching, and I'll give you updates next year. Bye bye.